You ready? All right. So I wanted to make a video on solving linear inequalities, but before I do that, I want to make sure, again, just to kind of give you a review what we've done so far. So we've gone over equations, and even though this is kind of a simple one, x equals 3 is an equation. And the difference between an equation and an inequality is just the sign that we use. So if you look here, we have the x is less than or equal to 3. So the only difference in this and this is this sign. Okay? And they have a big difference in their graph. If you graph x equals 3, okay, you just get a dot at x equals 3. But if you graph x is less than or equal to 3, you not only get the dot at 3, but you also get everything to the left of that. So your inequality has, in essence, more solutions than an equation. Okay? So what we're going to do now, though, is explain the difference in a linear equation. Okay? I'll walk this way. A linear equation and the linear inequality. And so if you look here, we have an equation here, and we have an inequality here. And the way you can tell, again, is because this has an equal sign, this has an inequality sign. Okay? And I'm going to show you the difference in how we actually graph those two. Okay? And so when we graph this, we've gone over this before. This is y equals mx plus b form. So I'm just going to write that to make sure you can see it. And what that tells us here is that whatever's next to the x is my slope, and whatever is without the x is my y-intercept. And so my y-intercept here is -2, and my slope is 3. Okay, so what this tells me is I go to -2 on the y-axis, which is right here. Okay, and so I plotted the y-intercept, and now I need to apply the slope. My slope is 3. Now that as a fraction is 3 over 1, which tells me I go up 3, right 1. So I go up 3, it's up 2, 3, right 1. And I can do that as many times as I want. 2, 3 over 1, and connect the dots. Okay, so this is the graph of a linear equation. And it's called a linear equation because the equation itself forms a line. Okay, but what about a linear inequality? So there's going to be some big differences. If you look over here, this looks exactly the same as this over here, except the sign. So this is y equals 3x minus 2. This is y is greater than or equal to 3x minus 2. Okay, so everything else is the same. And interesting enough, the graph is going to look almost identical, except one difference, and I'll show that in a minute. So we're going to graph this the same way, kind of like a y equals mx plus b. Okay, so we're going to graph the exact same thing over there. And so I'm going to draw this one in orange though. So the y-intercept is at -2, so we go to the y-axis to -2. And then we apply the slope. Okay, slope again 3 over 1. Okay, that tells me to go up 3 and right 1. Okay, so I go up 3, right 1, up 3, right 1. Okay, that's not that good. Okay. Now we're not finished here, but I want to make sure something is understood about an equation and inequality. The solution to an equation is what makes the equation true. So what I mean by that is every point on this line makes this equation true. Okay? So for instance, this point here, which is 1, 1. Okay, this point here, which is on the line, is 1, 1. So this point is 1, 1. Okay? If I plug in 1 for x and 1 for y, this should be true. So let's try that. If I plug in 1 here, I get 1 equals 3 times 1 minus 2. 3 times 1 is 3. 3 minus 2 does equal 1. So that is a solution to the equation. Same thing's true here. Any point that makes this inequality true is a solution to this inequality. So for instance, again, 1, 1. Let's try that. This again is a point on the line. Okay, so if we try that, we get 1 is greater than or equal to 3 times 1 minus 2. Again, 3 times 1 is 3. 3 minus 2 is 1. And 1 is equal to 1. Okay, the only difference is our solutions are not just on this line. Okay, they're on either side of this line. So what I mean by that is this line and everything on one side of this line is a solution. And in this case, everything on this side of the line is a solution. So the graph of an equation, a linear equation, is just a line, whereas the graph of a linear inequality is a line and everything on one side of that line. So in this case, it's on this side, and I'll kind of explain why. So everything on that side. Okay? So it's a line, then the whole area on one side of the line is the solution. Now, how can we check that? And what I mean by that is, let's choose a point that's in the shaded region. Okay? I'm going to look here at 0, 0. It's kind of hard to see. This point here is our origin. Okay? And that point is 0, 0. Okay? And that's in our shaded region. So let's see if I plug that in, if it gives me true. Okay? So this is our original inequality. And if I plug in 0, 0, that means my x is 0 and my y is 0. So I plug in 0 for y, 0 for x. I get 0 is greater than or equal to 3 times 0 is 0, minus 2 is negative 2. The question then is 0 greater than or equal to negative 2? Well, that's true, because 0 is bigger than negative 2. And so that is part of my solution. It didn't fall on the line, but it still makes the inequality true. And so the reason we shade in that general direction is because every point in this region, no matter where it is, will make this inequality true. Anywhere in the orange section. But anywhere in this non-shaded region will not make it true. Let's try a point. Let's try an easy one, 3, 0. This is 3, 0. Okay, so let's try that one. That should not make it true. And that means my x is 3, and my y is 0. So let's, again, this is my inequality. If I plug in 0 for y, and 3 for x. Okay, 3 times 3 is 9. 9 minus 2 is 7. So let's look at that. Is 0 greater than or equal to 7? Well, no. X or 0 is actually smaller than 7. And so that does not make the inequality true, which is why it's not shaded. Okay? So the only difference in graphing a linear inequality and a linear equation is when you graph a linear inequality, you're going to shade on one direction. Sometimes it'll be in this direction, sometimes it'll be on this direction, depending on this symbol here. Okay? Now if you look back over here, well actually let's do this. If I had, erase this. If I had x is less than 3, okay? We've already graphed over there x is less than or equal to 3, okay? Well, let's graph this one here. On this one, we have 3, and we have an open circle at 3, so we don't include 3. We shade everything to the left of 3. So the question then becomes, the only difference here is what if this was just a greater than, okay? Which would mean that in the same way that I did not include 3 here, I wouldn't include the line here. So instead of doing a solid line, so if we redraw this line here in black, instead of having a solid line, I would now have a dashed line, symbolizing that I do not include that line in my solution. In the same way that I'm not including 3 in my solution here, I'm not including the line itself. Okay? So, and that should be the end of this video.